Hi all, today we're going to be doing a very simple problem. The question states, find the coordinates of the point where y equals 8x minus 31 is tangent to the curve y equals e raised to x squared minus 16. Now, the reason I decided to make a video on this problem is because most of the problems of this type can just be solved by equating the y coordinates and the x coordinates, and so you get the coordinates of the point where they intersect. But this one is a bit different. If we try that approach here, this is what we get. We get e raised to x squared minus 16 equals 8x minus 31. And there's really no way to solve this equation unless you use approximate solutions. Anyway, what we're instead going to do, the question states that we have to find the point where y equals 8x minus 31 is tangent to the curve, right? So if it's tangent, we know that the rate of change of this curve is equal to the rate of change of this line, right? So let's find the derivative of this curve. So we have dy by dx equals 2x times e raised to x squared minus 16. And as for this line, we have simply 8. So we have dy by dx equals 8. And we know that these two have to be equal since it's tangent. So we have 8 equals 2x times e raised to x squared minus 16. And now we get 4 equals x times e raised to x squared minus 16. Okay, now at this point, we end up with something similar to the original equation we had when we equated these two lines. But now what you want to realize is, if it's tangent to the curve, I'll just draw a sample curve here. Let's suppose this is our curve, right? And there's this line here tangent to it. Right. Okay. So you can see that it's intersecting at exactly one point, and the rate of change of the curve at that point is equal to the rate of change of this line, right? So we know that therefore e raised to x squared minus 16 must be equal to 8x minus 31 since they intersect. So now we get 4 equals x times 8x minus 31 since they're intersecting, and we get 4 equals 8x squared minus 31x, and then we get this quadratic in x, 8x squared minus 31x minus 4. And on solving it, we get, okay, so when we solve this quadratic, we get two solutions, x equals minus 1 over 8, or x equals 4. And let's remember the assumption we made. We assumed that if the rates of change are equal, then the y coordinates also have to be equal, right? We know that 8x minus 31 and e raised to x squared minus 16. E raised to x squared minus 16. We know that these two have to intersect. And over here we're getting two solutions. So let's check if they intersect twice. So for the first one, we have y equals 8 times minus 1 over 8 minus 31. And that cancels off, and that leaves us with minus 32. And for the second one, we have e raised to 1 over 64 minus 16. And just from looking at this, I can say that they don't intersect at x equals minus 1 over 8. They don't intersect because this is going to be a really small number. Okay, now let's look at the case where x equals 4. We have y equals 8 times 4 minus 31, and this gives us 1. And for the other case, we have e raised to x squared, so that will be 16 minus 16, e raised to 0, and we know that this is 1. And therefore, this is a solution. And so our final answer is x equals 4, y equals 1. Thanks for watching this video. Have a nice day.